So here you have 2016 paper 2, this is question 1 and this is a question on probability. So the question says, a survey of 168 people was carried out. Participants were asked whether they owned a cat or a dog. Some of the results are recorded in the Venn diagram below. So something important that we might get out of that piece of information is that altogether, which I might put here, that the whole number of people that were included was 168. And it says, of those surveys, 19 people did not own either a cat or a dog. Complete the diagram. So this is people who don't own a cat or a dog. Here is a cat and a dog. Here is a dog but not a cat. Here is a cat but not a dog. So a cat only. So 19 people that don't own a cat or a dog is going to go here. So in order to find the number of people who only had a cat, well, the total number of this, and this must add up to 168. So if I'm to add 19 and 48 and 64 together, I get 131. So to find out how many people had a cat only, because that's the only other option, I do the total number of people minus 131. So that will give me 37. So 37 people owned just a cat. So then the next part 2, it says a person is chosen from random from those surveys. Find what is the probability that the person owned both a cat and a dog. So from all the people surveyed, so we want the probability. To get the probability that the person owned, I'll say probability of cat, C and D for cat and dog, will be the number of people who have a cat and dog. So people with cat, and I'll just say C and D for cat and dog, over the total number of people. So the number of people with a cat and dog is 64, and the total number of people they told us in the question is 168. So the probability that we have a cat and a dog is going to be 64 over 168. And say if we just wanted to break that down, that goes to 8 over 21, and it is a repeating decimal, so I might just leave it as 8 over 21. And then the next part, it says, part 3, what percentage of the people surveyed owned one animal only? So the total number of people surveyed is 168. So the people that owned one animal only are the people here and here. So one animal only is going to be 37 plus 48. So 37 plus 48, and that gives 85. So if I want to get the percentage of people, well, the total number of people is 168. So it'll be 85 over 168, and then by 100 to get my percentage. And then I get 50.5952, but they said correct to one decimal place, so 50.6%. So 50.6% of people surveyed had one animal only. And then the next part of that question, part B, so we're told that Mandy wants to buy a ticket to the theatre. She can choose to buy a ticket in the balcony or in the stalls. Mandy can go on Monday, Wednesday or Friday. For an extra charge, she can choose a VIP ticket where she will meet the band, or she can choose the show only. Complete the tree diagram below and hence or otherwise find the probability that Mandy chooses a VIP ticket on a Wednesday. You may assume that all choices are equally likely. So a lot of information I might take out of that kind of paragraph is that so she's going to choose either a balcony or stall ticket, So balcony or stall, and she's either going to go on Monday, Wednesday, that's Monday, Wednesday, or Friday. She can choose a VIP ticket or a show only. So there, it's kind of the 3 ways it could differ for her. So the type of ticket, the day she goes, and if she's doing a VIP ticket. So we're asked to complete the tree diagram below. So they gave us a tree diagram, and I'll just draw in what they've shown already. So this is what they've drawn in already, and I'll just use a different colour pen for the rest. So basically, she can choose, we know that she can go with a balcony or stall ticket. So that's the first thing she has to choose. So it's going to be B or S. So that's balcony or stall. But then, if she chooses a balcony ticket, she can go on Monday, Wednesday or Friday. So if she chooses a stall ticket, she could also go on Monday, Wednesday or Friday. So I'll just write these in, Monday, Wednesday or Friday. But then she has another option because she has to choose if it's a VIP or show only. So this is VIP and show only. So for Wednesday, there's an option for VIP or show only. And for Friday, there's an option for VIP or show only. Also for this, we have an option VIP, and then VIP show only and VIP show only. So what we have to do is now work out the probabilities. So so all choices are equally likely. So when we have 2 choices and both choices are equally likely, well, there's a half chance that she's going to choose a balcony ticket and a half chance she's going to choose a stall ticket. But say if we're here and she's choosing a stall ticket, well, they're saying that all the choices are equally likely. So there's 3 choices, so it must be a third chance that she's going to choose this one and this one and this one. Say if there was 4 choices, it'd be a quarter. So for this one, it'll be also, so say she's picked, say, a stall ticket on a Friday, well, there's a half chance because there's 2 options here. And say she's picked a stall ticket on a Wednesday, it's a half chance again because there's 2 options, and a half chance because there's 2 options. And it's the exact same thing here. We have 3 options, they're all equally likely, so it'll be a third chance of picking each. And here they're equally likely and there's 2 chances, so it's a half, a half, a half, and a half. So we want to find the probability that Mandy chooses a VIP ticket on a Wednesday. So if she's choosing a VIP ticket, so say if I want to work out, so say this case she has balcony on a Monday and it's a VIP ticket. So balcony, Monday, VIP, and say this one is balcony Wednesday, so we have balcony Monday and show only. Balcony Monday, show only. And then in this case we have balcony Wednesday VIP, and then we have balcony Wednesday show only, and we have balcony Friday VIP and balcony Friday show only. So if she chooses a VIP ticket on a Wednesday, so it's going to have to be a Wednesday and it's going to be a VIP ticket. But she could have also had chosen a VIP ticket on a Wednesday from a stall. So we're going to have to work out the probability that she got a balcony. So she could have either got a balcony ticket on a Wednesday, which was VIP, or she could have got a stall, because it didn't say if it had to be a stall or a balcony. A stall on a Wednesday and VIP. So when we have or in probability, we add the probabilities. But the first thing we're going to have to do is get the probability that she got a balcony on a Wednesday and a VIP. So when we have a tree diagram like this, we multiply the probabilities because she got a balcony, and in probability means we multiply. And or means we add the probabilities. So in this case, to get this probability, a balcony and a Wednesday and a VIP. So the probability of a balcony is a half, the probability of a Wednesday is a third, and the probability of a VIP is a half. So that's going to be a half by a half by 1/3, and that gives me 1/12. And say if I want to get the probability that she got a stall ticket on a Wednesday and VIP. So the probability of a stall ticket is a half, and a Wednesday is a third, and VIP is a half. So that's 1/12. So the probability that she got a balcony on this day, that she got the ticket this way, is a 12th, or this way is also a 12th. But when we have or, we add the probabilities, so the probability will be a 12th plus a 12th, which will be 2 12ths, which will be 1/6. And that is my answer for that question.